type of function that is called exponential functions. Okay, we're also going to graph them, so I'm going to introduce you to these functions, and then we're going to look at graphing them. Now, please copy your heading down like always. I would include today's date so that your notes are organized. Your heading is Exponential Functions, Lesson 8.1, and be sure and include today's date. Okay? Exponential Functions, Lesson 8.1, and be sure and include today's date. Now, here we go. If I go too fast, just pause the video. As usual, let's start off by first taking a look at what an exponential function looks like. Okay, so in your notes I would write down example of exponential function, and here it is. Here is an example. F of x equals 2 times 1/3 to the x minus 2 power plus 5, or positive 5. I'm going to ramble on about this, and I'm going to make some comments and draw some arrows. Please copy this in your notes. Now, first of all, understand that we do not have an exponential function just because we have an exponent. For example, here is a linear equation. And we have an exponent right here, okay? So just because we have an exponent does not make it an exponential equation. What makes this equation an exponential equation is the fact that we have an x, or a variable in my exponent. It could be a y, an a, a b, a c, or a d, or whatever. But since we have an unknown or a variable in our exponent, then we have an exponential function. Do you see that okay? As I always tell you, it's important that you look at an equation and in your mind you can classify it into what type of equation or function that it is, because on your tests, especially toward the end of the year when we're taking exams, I'm going to mix all these together, okay? So, this is an exponential function because we have an unknown in the exponent. Now, this, make note of this please, this x minus 2 is your what? Sorry about that. Is your exponent. Please write that in your notes. That is your exponent. Isn't that obvious? Sure it is, definitely. Now, is the 2 the base? Well, of course not. The x minus 2 doesn't go to the 2. In fact, the 2 has a power. It has an exponent. You just can't see it. Remember, it's a 1, okay? But the base of this exponent is 1/3. So I would circle that somehow in your notes and make note that's your base. Okay? This is just nothing. It's just a number being added toward the end of the equation. It's just a multiplier right here. But the main two parts you always want to be familiar with and know where they're at is the exponent and the base. Okay? So please make note of this. Back that up and listen to it again if you need to, if you're confused, okay? We have an exponential function because we have a variable in the exponent. Now, for the exponential functions we will be studying, the base will always be larger than 0. So this number right here, that number will never be what? It will never be less than 0. So in other words, it will never be negative. Now, I want to challenge you on your own free time because you love math so much, and of course I'm joking, but if you have the time, you ought to make, later on we're going to learn how to graph these, and after we learn how to graph these, you ought to take one and make your base. Now here your base is not negative, just trust me, it's not. We'll talk about this later, but you ought to try one where your base is negative. Just make one up and try to graph it, something like this, and try to graph that and watch what happens. Something interesting happens. Okay, we're not going to get into that today, but if you have some free time, make a problem up like this one, and after you learn how to graph these and use these 5 steps right here, try one that has a negative base like this, and something interesting happens, okay? But anyways, back to what I was saying. For now, the exponential functions we're going to be studying, the base will always be larger than 0. You will not have any negative bases. Everybody with me so far? Okay. Now, if you'll remember, we skipped lesson 7.2 earlier this year because I told you that we would get into exponential functions later, and now we are. At the end of chapter 8, we're going to go back to lesson 7.2, the one that we skipped, and look at some word problems from that lesson, lesson 7.2. Okay? Okay, let's get started graphing these functions. Now, as almost always, I give steps for graphing, and like I usually do, I will be giving you steps in just a minute. But before I do that, I want to stop and look at the basic shape of the graph of an exponential function. And I really think you should take notes on this, because I'm going to talk to you about something called an asymptote. Okay? Alright, here we go. Here's your y-axis. Here's your x-axis. Now, first of all, I would not write anything. I mean, I would go ahead and draw your coordinate plane here like I've done. That's fine. But just let me ramble before you draw the graph. The exponential graphs are going to look like this. Or they're going to look like this. They're always going to kind of flatten out at the bottom. Now, I mean, they're going to look like they're flattening out. In reality, they're always slowly getting lower and lower and lower, but they'll look like this. Also, this will look like it's eventually going straight up, but it's not. It looks like it flattens out, but it's always slowly, slowly, and slowly going more to the left, and this will always be going down a little more, okay? So go ahead and stop now and take some notes however you want to on that, but they'll look like that, or they'll look like this. They might come this direction like this, alright? Some of them might even be flipped like this and look like this. That could happen, okay? But again, they're going to look like they're flattening out here and flattening out here. And that's the general shape of an exponential function. It could look like this. It could go this direction. Do you understand? Okay? Now, every single exponential graph has what we call an asymptote. Okay? I would write that in your notes. That's huge. In fact, all of these graphs have a horizontal asymptote. I would write that down. They do not have a vertical asymptote, but they have a horizontal asymptote. Okay? So please copy that in your notes. All of these exponential functions will have a horizontal asymptote. Now, I should have had this typed in your notes, and I didn't, and I apologize, but I'll type it now, okay? So please copy this down. What is an asymptote? Here it is. Definitely copy this in your notes. It is an imaginary boundary that the graph will not cross. Okay, I would write that in your notes. It is an imaginary boundary that the graph will not cross. Now when I go to the next page, that's going to disappear. So copy that down, please. Asymptote, an imaginary boundary that the graph will not cross. So every single one of these exponential functions will have a horizontal asymptote. That means it's going to have an imaginary horizontal line that the graph will not cross. So like for this graph right here, even though you can't see it, there's an imaginary dotted line. Like this, the graph will not cross. So Mr. Arrow, you just lied to us. You said this graph here continues to go up and up and up. Well, it does. It does. It's crazy. Let's say we have 1, 2, 3, 4, 5. Let's say the horizontal asymptote was at 5 right here. 5. Well, that means this graph will go like 4.9, 4.99, 4.999, 4.99999, 4.9999999, but it will never, ever get to 5. It's actually pretty mind-boggling to think about. So every single one of these graphs will have a horizontal asymptote. Do you understand? And their shape will look like this, or this, or like this, or like this, okay? Alright, now let's go ahead and move on. If I've gone too fast, pause the video and take some more notes. Now here are the steps that you need to graph the these exponential functions, I'm going to go fast, expecting you to pause the video after I get down to number 5. So we're going to place the horizontal asymptote on the coordinate plane. I will teach you how to do that. Next, you set the exponent equal to 0 and solve. That is easy to do, no problem. Next, you take your answer from number 2 and put it in the middle of a table of values that holds 5 values. I will show you how to do that, although you should already know how to do that. Lastly, fill in your table of values, which we always do, and then sketch the graph. Now, I'm not impatient, but some students write faster than others. Some write slower than others, so I'm not going to wait. I'm going to go ahead and move on. You pause the video, copy down these 5 steps. We'll look at a couple of examples. We'll be finished, okay? Actually, 3 examples, I believe. Alright, so here we go. As you can see, this is not difficult at all. These 5 steps are simple. And let's try a couple of these, okay? So relax. Don't be nervous. Here we go. Copy this in your notes, please. This exponential function. Okay, here we go. Now, step 1 said, place the horizontal asymptote on the coordinate plane. Alright, so, you say, Mr. Earhart, how do we find the horizontal asymptote? It's so easy. It's always the number that's being added or subtracted to the base, not multiplied, added or subtracted. So, don't write this down, just watch. If I had something like this, my horizontal asymptote would not be 5, it's multiplying the 3. This would be your horizontal asymptote because it's being subtracted to the base. It's being subtracted to the entire exponential expression. Over here, your horizontal asymptote is this number here because it's being added to the entire exponential expression. So whatever number is being added or subtracted, either one, to the entire expression is your horizontal asymptote. Got it? Now occasionally, I might try to trick you and write it like this. 6 plus 2, 3, x minus 5. Okay, no big deal, guys, come on. You know as well as I do, you could pick up this positive 6 right here and put it on the end and put positive 6 there if you wanted to. Okay, so don't be fooled by that. Sometimes this number right here might be written out front. Well, that's okay. That's no big deal. This 2 is multiplying times the base. This is your other term right here that's still being added or subtracted to your entire exponential expression. So this would be your horizontal asymptote, okay? Not too difficult to see. And after we're done working your homework problems, you'll definitely have a lot more practice. So when I look at this, here's my number being added or subtracted to the expression. It's a positive 4, so my horizontal asymptote is right here at positive 4. Piece of cake. That's so easy to do. I went up 1, 2, 3, 4, put my boundary. Step 2 says take your exponent and set it equal to 0 and solve. Well, my exponent is x, so take x, set it equal to 0 and solve. Well, there's nothing to solve. X equals 0. Step 3 says take your answer from step 2 and put it in the middle of a 5-value table of values. So put that 0 right in the middle. So now we'll go up 1, 2, we'll go down -1, -2. Now, if you want to type this into your graph and use your table of values, fine. But please listen to me. You must type this into your graph for exactly how it's written. So for those who want to do that, you will turn your calculator on, obviously, and hit your top left button which says y equals. Now those that do not have a grapher, just be patient, okay? Hit your y equals button like you're supposed to, and then type this in. You'll hit your negative, not your minus. In the bottom right corner, you'll see a negative. Type negative, then what comes next? A parentheses, so put the parentheses, then 1/2, so 1 divided by 2, then close your parentheses. Then hit your arrow button. Got it? Then hit X, then hit +4. And that will work perfectly. After you've typed that in, simply hit your second graph button or shift graph, and up will pop your table of values. Okay, so that is how you would do that, and we're going to look at a couple more of those, just to make sure everybody understands that for those that want to use their table of values. Alright, now, for those that aren't going to use the grapher, let's put our values in very quickly. Let's put a 2 in for x. So with your calculator, you would type in into parentheses 1/2 to the second power, because we're putting a 2 in for x. See the 2? Putting it in for x. So 1/2 squared is 1/4. But what's in front? A negative. So negative 1/4 plus 4. That's 3 3/4. Or 3.75. Let's try another one, okay? Let's substitute 1 in for x. So I'll put a 1 in for x. So I have 1/2 to the 1 power. Of course, anything to the 1 power is just itself. Then bring down your negative sign, and then positive 4. So negative 1/2 plus 4, 3.5. Now we'll put a 0 in for x, okay? A 0. Well, anything to the 0 power is 1. So 1/2 to the 0 power is 1. Don't forget that. Anything to the 0 power is not 0. Anything to the 0 power is 1, okay? So 1/2 to the 0 power is 1. Bring down your negative sign, and then bring down your positive 4. Negative 1 plus 4, 3. Now, let's substitute negative 1 in for x. So I have negative 1/2 to the negative 1 power. Now if you're going to type that into your calculator, be sure and put parentheses 1/2, close your parentheses, arrow, and then negative 1. If you'll do that and hit enter, you will get out 2. Okay? So 1/2 to the negative 1 is 2. Bring down your negative sign, bring down your positive 4, and you'll get out a 2. Alright? Now, lastly, we'll substitute negative 2 into the equation. So I have 1/2 to the negative 2 power. Same thing. Type in parentheses 1/2, close your parentheses, arrow, negative 2. Hit enter, and you will get out 4. Bring down your negative sign from right here. Bring down your positive 4. Negative 4 plus 4 is 0. Look at that. We're done. Let's sketch the graph, and we're finished. 2, so over 2, up 3 3/4. 1, 3.5. 0, 3. Negative 1 is 2. And negative 2 is 0. Can you not see that curve taking place? So here's the graph. Comes up, hits here, and now when you draw it, I mean, I'm not going to take points off of your line, accidentally touches the horizontal asymptote, but it really shouldn't. It's getting closer and closer, but it will never touch that horizontal asymptote. Now, down here, this finishes up like this. It kind of looks flat, but it continues on and on to the left. The further down it goes, it continues to go gradually and gradually more to the left. There is no vertical asymptote. This graph will continue to go more and more to the left. This, though, it'll continue going up, but it'll be really gradual and never cross the number 4. Never. So that's it, guys. So we have our horizontal asymptote and our 5 ordered pairs and our graph. Not too difficult. Okay? What is difficult is learning to recognize each function and remember the steps for each type of function. Okay? Alright, let's try another one. Go ahead and copy this in your notes, and then we'll get into it. Now, the first thing you might notice, by the way, as you're copying it down, is that I've lied to you. I told you we wouldn't have any negative bases, and we do. But students, come on, I've really taught this to you pretty well. That's not a negative base. Remember, I've taught you if you have negative 2 to the 4th power, that's not the same thing as negative 2 to the 4th power. In this example here, your base is negative 2. So you would take negative 2 times negative 2 times negative 2 times negative 2, and you would get positive 16. Negative 2 times negative 2 times negative 2 times negative 2. Over here, this is not part of your base, so you'd bring the negative down. Then you would take 2 times 2 times 2 times 2, which is 16, and you would get have totally different answers because of the parentheses. Okay, so listen to me please. In this example right here, your base is -2. In this example here, your base is 2. How can that be, Mr. Error? This right here, see this? It's really this. That's the exact same thing. That negative sign is like having a -1 here with parentheses around the 2 and a 4. This negative is not part of your base because there is not parentheses around it like this. Your base is +2 and you would bring the negative sign down. So having said that, because there's no parentheses around this -2 right here, your base is not -2. Your base is 2 and you'll be bringing this negative sign down. Okay? So with that in mind, let's jump into it, students. Here we go. Step 1. Place the horizontal asymptote onto the graph. Okay? This is the number here that's being added or subtracted to the entire function, +2. So I have a horizontal asymptote at +2. Piece of cake, no problem there. Step 2, take the exponent, x minus 2. Take your exponent, set it equal to 0 and solve. That gives you a nice central figure of the curved graph. There we go. Bring the 2 over, make it positive. Step 3, take your answer from step 2, place it in the middle of a 5-value table of values. Then we'll go up and we will go down, just like that. And now having done that, let's get into this. Let's put it, no, by the way, oh, listen to me, students, please listen. If you're going to type this into your grapher, do it exactly like you see it, except I'm going to show you something. In the last problem, your exponent was only x. Okay, so when you put the arrow, you just put an x. Now it's a little different because we have 2 terms. We have x minus 2. So please, are you listening? If you're going to type this into your grapher, listen carefully how to do it. You hit your y equals button top left, and then you would hit -2. Don't put parentheses around it, just -2. Then hit your arrow. And now you do need parentheses because you have to tell your calculator that the entire exponent is x minus 2. Then close your parentheses and then put +2. So if you'll enter that into your calculator like that, and then go to your table of values, you can fill this out. Now again, if you don't have a grapher, you're only going to lose about 3 minutes. We can do this pretty quickly. It's not a big deal, okay? Here we go. We're going to put a 4 in for x first. So put a 4 right here. 4 minus 2 is 2. So I have -2 squared plus 2. Now remember, you're not squaring the negative, so bring that down. You're squaring the 2. That's 4. And then +2. So you bring the negative down because there's not parentheses around the -2. Bring the negative down. Square the 2. -4 plus 2 is -2. Now let's substitute 3 in for x, okay? So we'll put a 3 right here for x. 3 minus 2 is 1. So I have negative, then 2 to the 1 power, +2. 2 to the 1 power is 2. Bring down your negative sign. -2 +2 is 0. Next, let's put in a 2 for my exponent. 2. 2 minus 2 is 0. So -2, 0 power, +2. Well, bring down your negative sign. Anything to the 0 power is 1. -1 +2 is 1. Now let's substitute 1 in for x. 1. 1 minus 2 is -1, so I have negative, then 2, then -1, +2. Now, with your, well, first of all, bring your negative sign down right here. Bring that down, okay? Bring down your negative sign. Now in your calculator, if you type in 2 to the -1 power, you will get 1/2. Go ahead and try that and you'll see you'll get 1/2, okay? So 2 to the -1/2 is 1/2, or excuse me, 2 to the -1 is -1/2 or -0.5. Well, -1/2 plus 2 is a +1 and 1/2. Now let's substitute 0 in for x. Here's the x. I will put a 0. 0 minus 2 is negative 2, so negative, then 2 to the negative 2, positive 2. Now, bring your negative sign down. 2 to the negative 2, type that into your calculator. 2 exponential negative 2. Enter, and you will get 1/4. And of course, there's a negative sign here you brought down, so negative 1/4, positive 2. That's going to give you a positive 1 3/4. And here we go. And by the way, well, let me put the graph up here first. So, 4, negative 2, 3, 0, 2, 1, 1, 1 and 1/2, 0, 1 3/4. So you can see the curve taking place here. I'm not going to try to draw this very well. You guys know I'm not good at drawing things, but there's the curve getting closer and closer to the asymptote, but never crossing it. Coming down here and slowly looking like it flattens out, although it doesn't. It continues on. Now, as you notice, guys, as I wrote these numbers going down, see how it got closer and closer to negative 1 3/4? Well, I went 4, 3, 2, 1, 0. Put something like negative 20 in. Okay, let me show you something here. Negative 20. Alright? Just you don't have to watch, write this down, just watch. I'm trying to show you how it will never become 2. It'll be 1.5, 1.75, 1.9, 1.99, 1.999. It'll get closer and closer. It'll never be 2. I'm going to put negative 20 in for x. Watch this. So put a negative 20. Negative 20 and negative 2 is negative 22. So I have negative 2 to the negative 22 power. Now, I'm not sure what my calculator is going to do when I type this in, okay? Let's see what happens here. First of all, bring down your negative sign. And now type in your calculator 2, arrow, negative 22. It's probably going to give you something in scientific notation. Yeah, mine says 2.3841, 85791 to the negative 7 power. That means you're getting out this 0.12345623841857991, and then you add 2 to that. Okay? And you still won't be at 2. Let me help you see it this way. Here's the fraction you would get. Okay? If you did this with a fraction, you would get this. You would get 1 over 4,194,304, and then bring down your positive 2. So you see, no matter what happens, you're always going to get a negative fraction adding to a positive 2. So it'll always be less than 2. I don't care what. I don't care how high or how low you go in your x values. You will always get out a number less than 2. And that's why it's called your horizontal asymptote. I hope that made sense. If it didn't, that was just free. I'm not going to test you on that, but I'm trying to show you why the graph will never come close to, it'll come close, but will never cross the horizontal axis, the horizontal asymptote. Now, I want to show you one more thing and we're finished. Here it is. In an example like this, we're not going to graph it, but I need you to listen to me. Do you notice how there's no number being added or subtracted to this function? So in that case, you would put plus what? 0. Or you could put, if you wanted to, minus 0. Just to help you see the asymptote. So your asymptote would fall right on the x-axis. So here's the x-axis right here. Your asymptote would fall right on the x-axis right there. Okay? So there's the horizontal asymptote right there. So if there's no number, like in the last example, I had a positive 2. In the other example, a positive 4. If you don't have a number on the end, put plus or minus 0, and that will be your horizontal asymptote. Guys, I hope this video has made sense. I hope it's been a help to you. If you have